In this episode of Finogric Machine, we are dealing with my broken Dremel. Well, this is the patient. It has been serving me quite some time, like 12 years I believe, minimum. And it was still going strong, something like a week ago, and then, no more. The symptoms have been actually developing slowly. So when I switch it on, it doesn't run. It makes a sound like this. Well, there is a microphone. It's certainly trying to start. You can see there is a display for speed and it's blinking. And it has been displaying these sorts of symptoms maybe 5 years. And these have been developing worse and worse over the time, and now it won't run even if I wait quite a long time. It sometimes runs a little while, but then stops. So, I'm pretty sure that there is a capacitor inside which is now our culprit. But I need to take it apart, maybe clean it up and fix probably the capacitor there. Yeah, so let's go to my workbench and do this. Here is our patient and it has 1, 2, 3, 4, 5 Torx screws there, which are holding this case, which seems to be made out of 2 pieces that are held together. Then we have this clip here. I believe, yeah, it comes off like that. And then we have here something. Okay, we need to take the chuck away. Well, this is a collet here, like that, and then I can take that away. Okay. Well, my Torx handle is not very large, so let's see. The screw itself is like this. It screws into the plastic and makes its own threads into there. This seems to be about the same length. So far all the same. And they are all the same. Now it should... So what's this then? It's something... Well, let's see. This should... Yeah, it comes apart quite easily actually. Yeah. Okay, the bearings are held by the cover. Okay, good. And we have a discrete component, a controller here. What we are interested in is this piece of thing, and I would like to get it totally out from there. So now this should come out. And then we have, this should, yeah, it does. Okay, it's, there is this small wire going, it's actually, I don't know what this is. Well, it's for the field. Should do that, and then we that. Now we can get rid of that. Really nice. And now we have the plate here. Well, not too bad actually. This is, well, we probably have a triac here, some microcontroller, and we have electrolytic capacitors, 2 couples of them. It is my belief that the culprit is either one of those. I will change both of them. We need to take off 3 screws like that. It's a little bit sloppy, I don't like that. Well, it's the only one I have at the moment that is even near. Okay, this will do. Now we have different screws. Okay. There you go. Okay, and then we have this piece of equipment which, well, it is what it is. Let's not break it down. So, we have the speed, and these are very good quality. This is all in all in a very good quality thing. 2 electrolytic capacitors. Okay. We have 1 resistor here which is a little bit buckled. This is actually not interference. No, yeah, it is actually interference suppressor, suppressing capacitor. The brain of the operations is probably under this display unit. I don't need to go into there. But, lucky me, both of these capacitors are really easily changeable. This one is the harder of these, what's the capacitance? It should be reading somewhere. They have succeeded in putting it in a way that you cannot see the capacitance. That's bad. The big one is probably taking care of the power supply. So this might be our first concern, that capacitor. Well, there is a test point even in this side so that you can test whether the current is okay. There is a grounding contact for test. Because normally when they build these up, they test them somehow. So they put this into a test chip which measures some, puts it into action and runs a test cycle on that one. I'll switch on my sucking station and I will get rid of the solder of these capacitors, so then I just can pull them out. Let's see now. Well, this is an anti-soldering iron, so to say, which I can use to suck away tin from the joints, so that I can pull up the components without harming the PCB. I have to be careful with this one not to harm the display unit. Well, this works without the one, and then I have 2 powerful tip in this one. Let's choose a better one. Maybe that one. You can read the temperature on the side because this soldering iron, you choose the temperature by the tip. And well, I'm just wondering which one should I take. That one looks good. Yeah. Okay. It's small enough. And this is still 50 watts. So, and everything in the tip of this thing. So, switch on that one too. I will put new solder into these because the old solder didn't come out easily. So when I resolder them, this solder becomes more fluidy. So, well, yeah, it definitely flows better. Okay, and then I put some into that one too. This way I can pick up them more easily. Okay. Yeah. Yep. And now I can suck this new solder out. So let's start with that one. Oh yeah. So I first heat it up, then I rotate it in a way that it will actually cool the pin inside there, the wire inside there, and after that, and this is hard because I cannot I cannot do a rotation because of this display, but it should be. Well, it has the glue in it. It would come out, but this is horrific. They have glued all these capacitors here, so I need to break the glue like that. I don't want to break the circuit board by pulling the glue out, because that would be not good. Well, you need to cut the glue or something. It's just very mildly. Avoid cutting the circuit board. Well, the other one we need to warm up so it comes out. Yeah. Well, here we are. 1 microfarad, 63 volts. Okay. This I do have. Which way? Okay. Well, they have a method of, and now I will show something. I pulled it out and didn't inspect the polarity. But this is a traditional way of marking these, and I will show this now to you. Hopefully the camera will focus on that one. We pulled out a capacitor from this point, these two joints here, and you see that the other one is round and the other one is rectangular. Well, traditionally these are marked in all PCB design programs. This is designed by program, I believe. So they mark the negative terminal by rectangle. So therefore I don't need to pay attention when I pull it out. And yeah, this has soldering contacts on both sides. So you need to be really careful when you pull it out. And this glue is really, or cube or whatever this material is really something. Okay, now I got it out. And the next is that big guy. Well, it should be loose already. Let's see if the threads are loose. They are not. It's always. Oh yeah, that's loose. You need to see that. Oh yeah, it's totally loose. It's just now to pull it out from there. And this is a little bit interesting because it has. I need to break the glue. Okay. Oh, and I got the part of the resistor with it. Can we see the capacitance here somewhere? Because it's right under the glue. And this turns out to be mission impossible to. It really sucks. This glue is something horrific stuff. But it peeled off from the circuit board quite nicely. And it peeled off the protection from the resistor as well. Yeah, there is a Zener diode here in parallel with this capacitor. Let me show you again, you don't see it. This small round component here, that's a Zener diode. And it is in parallel with this capacitor, and as you can see, well, this is the positive side, I believe. So then this is the plus of the capacitor. So this all here is for well, it's the supply. And it's connected into there, and that's actually the current is coming through this resistor. This is also taking care of it's the power supply for this one. I will select the capacitor, this capacitor, the bigger one, using just the size of the capacitor. So here we go. Do we have something that's probably this is 330 microfarads. I need something that is small enough to be put inside there. It cannot be very large. Well, actually, let's see how large can it be. If the PCB is sitting here, and then we have the capacitor, it's right here. We could, no, it's there. We have plenty of room there. We can put thing like this quite easily there, and it still fits there. Why did they choose a component like this? Okay. So, actually, did I pick up the correct one? No, it's only 10 volts. I don't want to use that. I would like to have at least 25 volts, and then I would like to have ones that are really good quality. Well, there is one that is really good quality, and this is 10 volts again. Oh man. 16 volts, 330. That's one candidate. And that one. One. Okay, and this is industrial range capacitor. It's 100 microfarads. And that then, that's also industrial, and this is 660. Let's see if it fits there quite easily. That's third candidate. Okay, I will probably put this one there because this is industrial grade, and it's rated from minus, well, plus 5 degrees Celsius. And well, it certainly has enough capacitors for this purpose. Then we need 1 microfarad capacitor. Here we have a collection of those. And this one should be a little bit shorter. Well, these are tiny things. 1 microfarad. Oh yeah, okay. 1 microfarad, 63 volts, and 105 degrees Celsius. Minus. In these capacitors, there is always these are polarized. So if you put them wrong way around, they will not work. And well, in this case, the minus is marked quite clearly here. So the shorter terminal is minus. So I put it there, and as it happens, well, this I have to test this somehow. Is there? Does this go somewhere here in a way? Well, like that. Well, I will actually, what I will do here, I don't put it straight there, I will give it some, I will put it like this, so it can be bent like that. I would like to have it not in this position, I would like to have it there like laying out like this. So that, for that reason I just take my pliers and bend the wires in a way that I want them to be. Like that. I make them like that. So now I can put it there. This is some silicone rubber. Now you have it there. Nothing penetrates that one. So, let's see again here. Now you can safely assume that we are there. Well, I just solder it this side. You can do this as well. And the other one, well, now I can do it traditionally from this side. The outer pin. I would like to have these kind of repairs so that the printed circuit board is separated from the device altogether, but you cannot have everything. Now I solder it also from this side, so, and then I will see on the back side that we have, no, we didn't. This is always the case that it doesn't flow through. I want it to flow through, really to be soldered well from the both sides. Okay, now this is there. Okay, 600. Well, and these are very specific cutters. I will show you so you understand. This is a design which has the cutting edge. It's not on the side, but it's on the tip there, like that. So this way you can go very close in very tight places easily and cut away. But of course these cutters, you don't cut no steel, just copper, and there is a maximum thickness of the copper wire you can cut with this. And it's not 1 millimeter, it's something like 0.5 millimeters. And now we have this here in a very, I should say, elegant way. And then we have this small animal here, which is also, I would also like to put this one in the similar way, so that, would I? Yes, I would, because there is this pole for screw. So actually, now which one was minus? The outer one. And in this case, well, also the solder lead, solder wire is minus in 90 degrees. Yeah. And then just eyeball the other wire there, so that it is about in the correct, like that. So we have it, we can put them a little bit vertical, horizontally, vertically, well, in a good orientation. This doesn't need to be isolated, I just solder it there. And this one is the one that has, okay, I managed to get it past the glue. That's always a good thing. Well, the capacitor is not sitting upright, so in its correct orientation right now, but I can bend it straight if I want. You didn't need to, but I want to have them nicely there. Okay, then we go this side, and now I will cut these. Well, they are still quite long. Okay, this works as a support here. Oh, well, yeah. You need a really small tip on your soldering iron when you are doing things like this. And that's a good joint. Then we wait it to cool down so that it doesn't drop when we do the other one. Oh yeah, okay. I think we have replaced the capacitors, which I believe are the culprit for this non-functionality here. But I might be wrong. I'm known to be wrong quite often. So I will show you the joints now. So what we were soldering were these two here and these two here. And on the other side we have the big capacitor, which was really, I believe that one was 100 microfarads, now we have 600. You can have extra large capacitor there. It's just smooth out, and it's a power reserve for the control circuit. And then we had this 1 microfarad capacitor, which again is actually critical. The value is critical because it's some sort of filtering or time constant or whatever. So now we should be able to test it like that. And since this motor doesn't, the bearings are supported by the case, you need to put it back together before you even start it. Okay, let's put this one as well there. Well, it rotates freely. And now, this is the moment of truth. Wish me luck. Nothing. Nothing. Not even a... Man, it's the resistor, actually. I believe it is, that's the next one I need to address here. Okay, you cannot succeed every time. Measuring equipment here. I have a special probe, which is this one. It has a very sharp, this is a needle. So this one I can put through layers of lacquer, protective layers, etc. I can push it through, put it into a tin, and everything like that. Then we need a minus, which could be, well, a normal and this is a normal probe without any gimmicks. So common that. Then we have this on 200 volt range. That's our, let's see which, okay, now it's switched on. There we have that one. Let's see if we already have some voltage in there. Let's see now. And this is dangerous. So if you do these kind of things now, there is 200 volts here. It can kill you. Well, this doesn't have any voltage in it at the moment, and it's switched on. Let's switch it off. Let's see if it changes the situation. Yeah, it's still nothing there. So it doesn't give it power. There is no power for that. So it's definitely the resistor, which we peeled off the things off. So now I need to take the capacitors off first. Well, that's not bad. And then I need to peel off the epoxy from here. Oh man, this is so bad. I hate this. Really I do. When they put that thing... See if I can now pull these out without any trouble. I should be able to do that. Wow, we need that. Well, now it vanished from that side too. And that as well. It's very important to get it off from the back side, on the top side as from the back side. This is a two-sided PCB, so you don't want to mess up the threads here. Well, I got it out without damaging anything. So now we can concentrate on this resistor, which I believe is our... And there might be, with a good chance, we might have the value readable on the underside. Let's see. Well, I could warm it up really. How high temperature? 250 degrees. This is, well, it's a heat gun with adjustable temperature. At the moment it's 250 degrees. And I'm warming up the epoxy mainly here. Let's see if I can, if it's any oh yeah, it did soften. So now I probably can put a utility knife blade under there and try to peel it out. Yeah, warming up made all the difference. Oh yeah. Yeah. Oh yeah. Now it peeled off. So let's continue warming it up. Now I try to get this. So 24 kilo ohms. Could it be? And then that one too, but that's a little bit later. Now this should come off. Oh yeah, I have to be really careful because there might be components under there hidden. Okay, in this case not. I just don't like this stuff. Oh yeah, there you are. So, now we need to go into there. Well, my nightmare would be that the whole thing had been embedded into this kind of stuff. Well, in this case I would have given up right away and sought for internet for these kind of controllers. I believe they are available somewhere. But yeah, let's see if I can just pull it out from there. Well, not entirely, but quite well actually. A lot better than I thought first. Okay. Oh yeah. We are clean. Grip it from here and then I warm it up from this side and there you are. Clean as a whistle, and then this one from this side. Where is the hole? Oh yeah. Now it's clean. So we can put our resistor in there. Okay. I did find two resistors. I didn't find the 24 kilo ohms. I have one 27 kilo ohms one and one 22 kilo ohms. Well, I will actually try with the 22 kilo ohms. Well, it doesn't fit there correctly, so I need to bend the wires quite near. I don't use the pliers for this one because I cannot get so close to the epoxy body of this one. So now I have bent the wires, and then let's see if we can have it into the place. Well, it's pretty tight in there. Now we need to form the wires a little bit so that it goes nicely into there. You don't want to push this thing. I will show you what I did when I get this ready. So you don't want to push it into the holes if it doesn't want to go there. So I bent the wires a little bit, like that. Please notice the corner here. So it makes it a little bit smaller. Now it should go there without any effort, and it did. Let's see that we have it in correct place. Yes, we do. And now I just solder it into place. See that it's, oh yeah, it flowed to the other side as well, and that's good. This one too. This is trying to escape on me. Now this one too, yeah. This went as planned, and now we cut the wires suitably here. to my metal trash bin these small wires. Okay, it's there. The resistor is now there. Then we take the big capacitor, put it back. I put this partially together. Now, wish me luck with this one. We still need the power. Yeah. Okay. Now we have replaced one resistor as well, and now I will only put the cover without the screws there, so we will test it without the screws. Okay, now I will connect it to our power supply, please. Oh yeah, we have a number there. Well, it's running. I believe some time constants have been changed here. It was the 24 kilo ohm resistor, I believe. It should be something else, but it's working. And it's telling 5, yeah, it's... Well, it was the resistor and probably these capacitors. Well, now I will check the temperature of this resistor. I really want to check it out. Well, it certainly warms up, but not a lot. I could say that it can dissipate this heat somewhere. Well, the design is really bad somehow. Putting a heating resistor near a capacitor, electrolytic capacitor, so that they are in thermal contact with each other. That's really bad design. It means that it will actually warm up the capacitor, which shortens the life expectancy of that one greatly. I fucked up some time constants there, so now it's giving me a little bit, let's say it gives me some speed variation here. This sounds nice. Well, it's not too bad. It's okay. I can live with that one. Well, I think it's fixed. Eventually we had 3 components we needed to change there. Well, only 3. Hopefully I didn't strip. No, I did not strip the threads, I mean. That's okay now. Then we had this. Well, which way? This way. Just put it there. It's probably wrong way around. Yeah, it is. We should have it not this way, but this way. Yeah, okay. Oh yeah, now it hangs well there in the wall. That thing. Then we have the collet somewhere. Oh yeah, I found it. Ooh, yes. This would have been miserable to find in the floor. So now that's the collet, and yeah, then you can do whatever you want. Okay. Yes. That's a good result for this repair job for my Dremel. Well, it now works really nicely, exactly as it should. And well, this has, well, 33 is the maximum. And let's see if it's, this is 5000 RPM and up to 33,000 works very nicely indeed. And well, after all, with the correct tools, this is an easy job. But if you don't have this kind of equipment, it might be a little bit well, difficult to do. But well, I can imagine that with a decent DVM, digital voltmeter, or maybe analog as well, and a good soldering iron, not the one you are soldering your car body, but a good one which has a very small tip and a well controlled temperature range. And by cutting the wires of the components and then cleaning the holes properly, you might be able to pull this through. But it's actually, I can tell you that it's one of the tasks, well, the PCB was not the best one to repair. So, and this should be done properly. If you don't do it properly, you would let it go. Just find a new board and that's it. Well, that's about this episode. In the next episode of Finogrid Machining, we are going to maybe we are going to do something for that rotating welding positioner. I believe it is the foot that it is sitting on. So that's the next one. So till then, sorry. Till then, see you!